This lesson is on dilations. Dilations are another type of transformation. So it's going to be, again, how something changes. When you hear the word dilation, you probably think of getting your eyes dilated at the eye doctor. That's when your eyes get really big. Okay. So let's go ahead and look at dilations. A dilation is a transformation that reduces or enlarges a figure to create a similar figure. In a dilation, the figure is enlarged or reduced to a fixed point called the center of dilation. This is similar to that center of rotation, so that point where everything was rotated around. This is going to be a point that everything was dilated around. The scale factor, that's an important word, of a dilation is the ratio of the side length of the image to the corresponding side length of the original figure. The corresponding sides are proportional. Okay? All right, so for the coordinate notation for a dilation, xy is our one coordinate. It's going to change to kx or k times x and ky or k times y. Okay, now k is the scale factor. So if the scale factor is 5, I'm going to multiply whatever x was by 5 and whatever y was by 5. That's how I'm going to change that dilation there. Okay? Reduction. Okay? When we're reducing something, we know that it's got to be smaller. That scale factor, k, has to be less than 1, but greater than 0. And don't forget, k is that scale factor. And then for enlargement, to make it bigger, literally the word large is in there, okay? That scale factor has to be greater than 1. Has to be greater than that original point. All right, so in enlarging a figure or making it bigger, we have triangle ABC. We're going to draw a dilation of ABC with vertices A, B, and C are right there, and use your scale factor of 4. So K equals 4. I would rewrite your coordinates. A is 1, 0. B is 3, 3. C is 3, 1. And what did I say that I needed to do with that scale factor? No matter what it is, I'm going to multiply it by each value, my x value and my y value. So 4 times 1 is 4. 4 times 0 is 0. That's our A prime. B prime, 4 times 3 is 12. 4 times 3 is 12. Multiplying it by x and y. And then C prime, 4 times 3 is 12. 4 times 1 is 4. And then go ahead and graph your dilation. I'm going 4, 0. 12, 12. And then 12, 4. That was A prime, B prime, and C prime. That figure was dilated or enlarged with a scale factor of 4. Example 2, we're looking to find the scale factor of the dilation shown. If it was me, I might go ahead and trace that enlarged figure. And now I'm going to look. My A, the original coordinate, that's the origin right here, was -1, 0. Oh, you can't see that. I'm sorry. B's original coordinate was 1, -2. C's original coordinate was -1, -4. And D's original coordinate was -2, -3. And now we need to figure out what happened to get it to this A prime, B prime, C prime, and D prime. The coordinates for A prime are -3, 0. The coordinates for B prime are 3, -6. The coordinates for C prime are -3, -12. And for D, -6, -9. So what was the scale factor? What did they multiply every x and y value by to get to our new dilation? That scale factor is 3. That's the scale factor of the dilation. I knew it was going to be greater than 1 because that second figure enlarged. It got bigger. And then the last bit is reducing a figure. We're going to draw a dilation of a quadrilateral, ABCD, with the vertices listed using a scale factor of 1/3. So I know automatically that this is going to shrink or reduce because my scale factor, or K, is 1/3, which is less than 1. Okay, remember our scale factor is going to be between 0 and 1. All right, so our original points, A is at 0, 12. Point B is at 9, 9. C is at 12, 6. And D is at 3, 3. Now I'm multiplying every x and y value by 1/3. 0 times 1/3 is still 0. 12 times 1/3. So 12 times 1 is 12, divided by 3 is 4. 9 times 1 is 9, divided by 3 is 3. And the same for that. B prime is 3, 3. Here's 12 again. 12 times 1 divided by 3 is 4. 6 times 1 is 6, divided by 3 is 2. And then D prime. 3 times 1 is 3, divided by 3 is 1. So 1, 1 is D. Okay. Now let's go ahead and graph that dilation, that reduction. Okay. 0, 4, 3, 3, which overlaps. That's okay. A prime, B prime, C is 4, 2, and then D prime is 1, 1. That's your figure reduced. Okay. All right, example 4. We're going to find the scale factor of the dilation shown. So I have the big triangle, and I'm reducing it to the little one. I know that this is the small triangle is the copy because I have the prime hash marks next to each of those points. All right, so A's original point is -5, 10. B's original point is 5, 0. And C's original point is -5, -5. And I want to see what happened to get to A prime, B prime, and C prime. Okay. Well, A prime's at -1, 2. B prime is at 1, 0. And C prime is at -1, -1. So my question to myself is, what did I multiply each of these original x and y values by to get these new coordinates? This scale factor, the answer is 5. 1/5. We're multiplying by 1/5. So essentially we divided by 5 or multiplied by 1/5. Because I had to go from this to the smaller points. I knew that if it was getting smaller, that my scale factor would have to be less than 1, but greater than 0. Okay? Your left-hand page, there's 8 questions. I want you to attempt them all. You do not have to graph 1 through 5, but I do need you to find the coordinates of those new vertices after the dilation. The code word for this lesson is purple. If you have any questions, please email me or send me a remind text.